temperature dependence of rate of reaction, where we will discuss the effect of catalyst on the rate of reaction. All right. Now, temperature dependence of reaction, the chemical reaction, it is directly proportional to the temperature in most cases. Okay. If there is a rise in temperature of 10 degrees Celsius, the rate constant, it will double. All right. The Arrhenius equation, which is given here, okay, it explains the dependence of chemical reaction on temperature. Here, Arrhenius equation is given for rate constant, that is K is equal to A e raised to power minus EA by RT, where A is what? It's the Arrhenius factor, also known as frequency factor. Okay, R is the gas constant, EA is the activation energy. What is activation energy? Activation energy is the energy required. It is the energy required to start the reaction. All right. This is called activation energy and it is represented by EA. Okay. Let us take let us see in a graph here. This is a graph between energy and reaction progress. Okay. Where the reaction is being started and it reaches a transition state. This transition state is what? It's a stable state. Okay, where we can calculate the activation energy. All right, and after some time the energy, it starts dropping and the reaction completes. Okay, it goes to its final state. We can illustrate this diagram also like this. Okay, now these are the reactants which are forming a product. There is one state at which it attains the higher concentration, or say the activation state. This state is called active. This transition state is achieved by activation energy. It is also known as activated complex. Okay. Now, if we calculate the difference between this reactants and products, the energy of the reactants and products, it will tell us the enthalpy of reaction. Okay, the difference between the energies of reactant and product, it will tell us the enthalpy of reaction. All right, let's take an example here. Here is an example of H2 plus I2. They are forming 2HI. Okay, while combining, this is a combination reaction. While combining, there is a formation of intermediate, which is what? This is the slowest step, or we can say rate determining step, right? And then the product is formed. Okay, so how the reaction progress? Okay, there is a reaction coordinate which tells us there is a change in rate in the beginning of the reaction and in the start, in the beginning of the reaction and in the end of the reaction. All right. Now, we can also understand the distribution of kinetic energy by plotting what is kinetic energy? That is movement of the molecules. Okay, as you can see here, the graph for most probable velocity. This is a graph between kinetic energy and fraction of molecules. What is the fraction of molecules? That is number of molecules with energy and the total number of molecules. Okay. Now, for this, with the help, the most probable kinetic energy, it is the energy of the molecules with maximum fraction. Okay, when the molecules, they attain maximum fraction, or say transition state, or say most probable kinetic energy. Okay, this is a graph for that is showing energies among the gaseous molecules. All right, from this plot we can calculate the activation energy, Thus, the rate of reaction, we can say that it is increased by increasing in temperature and decreased by and decreasing the activation energy. All right. Now, what is the effect of catalyst? It does not alter itself, but it enhances. Does not alter itself means it does not take part in the chemical reaction, but yes, it enhances or say it increases or decreases the rate of chemical reaction that we have discussed. Okay, if you can see in an example here where the decomposition of potassium chloride, it is taking place. Here KCl3, it is getting decomposed, okay, to form oxygen, where we have used MnO2 as catalyst. Okay. Now what we see in this reaction, that the chemical reaction, its rate is slower down by this inhibitor. Okay. Right. So we can understand the intermediate complex theory from this, that catalysts, they help in the formation of intermediate complexes. All right. And it decreases the activation energy, all right, between reactants and products, and create an alternate pathway for mechanism. All right. This is a catalytic reaction graph where a catalyst at different temperature is showing rate of reaction. Okay. The temperature, this side is showing with the increase in temperature the activity. Okay. And then there is a denaturation occur, that is at some point we achieved an activation energy, and after then the rate it decreases. All right.